Good afternoon.
Good afternoon, sir.
Good afternoon.
Okay, so let us begin with today's lecture. I was expecting everyone to join sharp on time. We will continue what we did yesterday. We had solved one problem on velocity. We had used relative velocity method. Let us take one more example and let's solve one more problem on velocity diagram using relative velocity method. Let me know if you have any questions. Please stop me in between and ask your questions so that after completing this, I can ask you for discussion. Hello. Am I audible?
Double.
Please mute yourself. Please mute. Now, am I audible?
Yes, sir.
Yes, sir.
Right. So please mute
Yes, sir.
at your end. Whenever it is required, you can unmute and you can say. Is that okay? Right. So let's go ahead. Please mute. Do not unmute. So this was the problem that we had solved yesterday. Don't look to this. This is a different. Just look to the procedure. This is the procedure that we followed yesterday. Draw space diagram or configuration diagram first. Locate all fixed points in a mechanism as a common point in a velocity diagram. So if there are 3 fixed points, all those will be treated as one common point. And from there you should start drawing your velocity diagram. Decide appropriate. Hello.
Sir,
Screen is not able to see
Screen
the
is not
screen.
visible. Yeah.
Yes, sir.
Please.
Yeah.
Let me do that. Is it visible now?
Yes, sir.
Yes.
Okay.
Yes, sir.
So let us go through the procedure once again so that you will recall what we did yesterday. First, draw space diagram or configuration diagram. Use scale factor if required. If not required, let us do it with scale factor 1:1. Locate all the fixed points in a mechanism as a common point in a velocity diagram. So if there are 3 fixed points, for example, all those 3 points will be considered as a common point, and from there you should start drawing your first vector of velocity diagram. In the problem that we had solved, there were 2 fixed points, and those 2 fixed points A and D were considered as a common point, and from there we had started drawing our velocity diagram. Then decide appropriate scale factor for velocity diagram. It can be 1:1, it can be scale up or it can be scaled down depending on your requirement. Construct the table for velocity diagram. This was the table. Construct the table for velocity diagram. This is the standard form of a table for velocity diagram. You may not find such tables in any books. I have devised this table. Preparing such a table while preparing velocity or drawing velocity diagram will help you a lot, because you will be able to get all the information required to draw velocity diagram in this table. Once you complete the table precisely, job of drawing velocity diagram will become quite easy. Represent velocity of each link with information of each vector from above table. So these are different vectors. Information for every vector is available in this table. What is that information? Magnitude and direction. Magnitude and direction is known. So use the information for every vector from the table and then represent velocity of each link using this information of each vector from the given table or table that is prepared earlier. Start with crank. Always start with input link, input crank, driving link, and draw vectors sequentially up to slider. In case there is a slider. In the earlier problem that we had solved, there was no slider. What I mean to say is start with driving link and then draw vector sequentially up to last link in the mechanism. Direction of slider velocity is always parallel to slider motion. We haven't seen slider in earlier problem, but if there is a slider, its direction of velocity is parallel to motion of the slider. For rest of the links, except slider, rest of the links have their velocities perpendicular to link lengths. For all other links in the mechanism, except slider, direction of their velocities will be perpendicular to link lengths. Use velocity image principle to find velocity of any point. Let's see when need arises, we'll see what is a velocity image principle. And calculate velocity of each link from velocity diagram drawn. Velocity diagram is nothing but a vector diagram. Even acceleration diagram is a vector diagram. From this vector diagram, determine velocity of each link as velocity of a particular link is equal to its vector length from velocity diagram multiplied by scale factor. That is how you will be able to get velocities of unknown links. And this is something we got yesterday. Right. Now let us move ahead and then let's try to solve one more example. Now this is the mechanism. Please click a photograph of this mechanism so that when I'll be drawing this mechanism configuration diagram, it will be there in front of you. Please draw a photograph. Please click a photograph of this mechanism. Now this is the given mechanism. We have to redraw it. We have to first draw space diagram. Got it? Shall we start drawing it?
Yes, sir.
Yes, sir.
Okay. So let us first draw space diagram. And once we draw space diagram, we will be then able to draw velocity diagram. So let's begin. Right. So first, let me tell you, you can set the units here. Go to this symbol, click here, go to drawing utilities, go to units, click on the unit, and you can set your units as millimeter, inches, feet, centimeters, meters, kilometers, etc. I have set the unit as millimeters. Got the point? How to set the units? This symbol, drawing utilities, units, and then set the unit. I have drawn a block here of 4000 by 4000 mm. I just have drawn it approximately, thinking that 4000 by 4000, square of 4000 by 4000 will be enough for me to draw the space and velocity diagram. Therefore, I have prepared that block so that I can prepare my space diagram and velocity diagram in the block, in this block of 4000 mm by 4000 mm. Okay. Next, so let us draw one horizontal line here. Don't think of any dimension right now. Let me check if all OSNAP settings are on. Yes, they are on. It will be easy for you when OSNAP settings are on. Let us draw one more line. And then no, let us draw this line. From this point, and let us check if it is correct. Check if both the lines are joined with each other. Okay, and then I have to draw an inclined line whose length is equal to O2A, na 50.8 mm. So what we should do? Shall we scale it up, or we have to draw it as it is? Shall we scale it up? Let's say this is the point. Let us scale it up by 10. Scale it up 10 times. Hello.
Yes, sir.
Let us scale it up. Hey, baga, if you will not scale it up, what will happen is it will be too small. How much it is? 50.8. Too small. That is the reason let us scale up. So it is 508. Okay, let's do it like this. First, trim it. Okay, and then here let us draw a line of 508 mm. No, from this point line 508 mm. So I have drawn a line of 508 mm, and then let us rotate it. Base point, angle is no. Rotate, select this line of 508 mm, select the base point and select angle. Angle is 45 degree. Yes or no? Angle is 45 degree from horizontal, na? Hello.
Yes,
Yes,
sir.
sir.
Right. So 508 mm, I have increased it by 10 times. Angle is 45 degree. So this is that line. Then next thing that I need to do is what else is given? What else is given here?
AB.
AB. Okay, let us do one thing. Let us locate this point at 102 mm, right? O2 point is at 102 mm. 102 means 1020. So let us draw a circle of radius 1020. This is that point. Now from this point, this is that O2 point. Right. Now next, AB plus BC, how much it is? अरे AC दिलाय ना, how much is AC? How much is AC?
203, that is 2030.
multiplied by 10.
2030.
Right. We know A point is known to us.
Yes, sir.
So this is that A point. Right. Okay. This is that A point. From point A, we should draw a circle of 203 mm, 2030, such that it will intersect horizontal line. This horizontal line. Which one? This horizontal line. How much is that? 2030. So what we got? We got A we got this point. For that, I think intersection is there. No. Okay, so it is joined here. So what we got? O2, A. Let me just draw it here. What is this? Oh, is it? O2, right? O2. Right, let us first complete the drawing. Then we will name it. So, right. So, now let us delete these two circles. Now this circle is still required. Now from point A, how much is AB? 102, right?
Yes, sir.
102 म्हणजे 1020. So from point A,
02.
so from point A, draw a circle of 1020. 1020 mm. This is that point, and from this point, which one? O1, So you will get this point. Which is this point? This is B. This point is B. From B, again draw a circle. How much is BD? How much is BD?
1020.
102.
Yes, 102 means 1020, right? And how much is O2D? O2D is again 102. So from this point,
102.
yes, again 102. So from this point, 102. No, sorry. From this point, 1020. So what I can do now is I can draw a line from here to here and line from here to here, and then delete all these circles. Delete this line also. Now let us keep this line. This is just to indicate that it is a point. That's it. This is just to indicate that there is a point here. Again, here to just indicate that there is a point here. Okay, have you got how to, have we got this configuration diagram? Let me again trim this. This portion should be trimmed. This. Right. Hello, everyone, all the students. Have we got the configuration diagram?
Yes, sir.
We got the configuration diagram?
Sir.
Yes, sir.
Yes. So don't consider
Yes,
these
sir.
lines. Don't consider this line and this line. These are just to indicate that these are the points, two fixed points. That's it. We have completed given configuration diagram. Right. So this is 1020. Let us dimension everything now. I have increased the font size so that you will understand all the lengths. This is 508. Then This is 1020. This is again 1020. 1021 actually it is. This is the dimension. This is AC. Right? 2030. These are all dimensions. Now let us go ahead to draw velocity diagram. Now tell me how many links are there. Please tell me names of the links. What is the next step after drawing configuration diagram? What is the next step after drawing configuration diagram?
Table.
Hello? Hello?
Getting the link name.
Drawing velocity diagram, and in that we have to prepare this table, velocity table. Which are the different links in the sequence? Tell me names of the links. तुम्ही सांगायचे आहेत मला आता नाव.
O2A.
Just a minute. O2A. Next. AB.
AB,
Next.
BC,
BC. Next.
BD,
BD. Very good.
DO6.
DO2 आहे ना? सॉरी DO1 असेल ते.
How to?
DO1 आहे O1.
दिसेना झालंय व्यवस्थित.
ओके ठीक आहे. DO1. Now velocity components. पहिला velocity of A with respect to O2. Next, velocity of B with respect to A. Please observe it carefully. Please observe what I am writing. Velocity of C with respect to B. Slider. And then it is velocity of D with respect to B. And then finally last is velocity of d with respect to O1. What are the vectors? जसे आपण velocity लिहितो त्याच्या बरोबर vectors. बरोबर ना? O2A, then AB, then BC, then BD, and then O1D. Right. These are the velocity components and vectors. Now, next thing that we should do is calculate velocity of the.
Hello, sir.
Yes.
Sir, how did you get velocity component for link name O2A?
See, that is vector.
Okay, okay.
That
Sir,
is
but
vector.
तुम्ही म्हटलं velocity component link name च्या उलट्या येतात ना?
बरोबर. मग मी velocity कशी लिहिले? Velocity of A with respect to O2.
Okay, okay, okay.
मी कशी लिहिले velocity बघा ना. A point is moving, O2 point is fixed. Please look into configuration diagram which is there on your mobile.
Okay, sir, got it.
A point
Sir,
is moving or
last
O2 point is moving. Which one is moving? Which one is moving? A is moving or O2 is moving?
Sir, A is moving.
So it is velocity of A with respect to fixed point, O2.
Okay, okay.
That is something which I have written here. Then next I have written velocity of B with respect to A. Then next velocity of C with respect to B. Then velocity of D with respect to B. Finally velocity of D with respect to O1. Velocity of O1 with respect to D लिहू शकत नाही मी. का बरं? Why I cannot write? Because
Fixed link.
Very good. Not fixed link, fixed point.
Also a fixed point.
O1 is fixed point. O2 is fixed point. So O1, O2 cannot move. So you cannot write velocity of O1 with respect to A. You cannot write velocity of O2 with respect to D. Sorry, velocity of O2 with respect to A, you cannot write. Velocity of O1 with respect to D, you cannot write. Right? And as far as velocity of B with respect to A or A with respect to B, both are possible because both the points are moving. Velocity of D with respect to B or velocity of B with respect to D, both are possible. Velocity of C with respect to B or velocity of B with respect to C, both are possible.
Okay.
Got the point?
Yes, sir. Thank you.
And when you have written your velocity components, then just don't think much. Vectors are to be written exactly in opposite way the velocity components are written. Since I have written it as velocity of A with respect to O2, so vector is O2A. Here velocity is BA, so vector is AB. Here velocity is CB, vector is BC. Here velocity is DB, so vector is
BD.
BD. And here velocity is DO1, so vector is O1D. इथपर्यंत क्लिअर आहे का सांगा? काय शंका आहे? Whether everything is understood up to this point?
Sir, clear.
Yes. Okay. If there are any questions from anyone, please let me know your questions, because now we are going to calculate velocity of crank. I have told you earlier, what I suggest you is, there are few important points that I'll be talking about, I'll be uttering those words, I'll be writing something in the chat box. Please note down all those important points in your notebook. Please make a note of all those important points. Now, let us Go to chat box. And now let us calculate. Let us calculate velocity of crank, because I have told you earlier, unless velocity of at least one link is known to you, you cannot proceed and draw velocity diagram. Is that understood?
Yes, sir.
Yes, sir.
Yes. So let us calculate velocity of crank. Velocity of crank, for that angular velocity of crank is given. Angular rotational speed is not given in this case. Directly angular velocity is given. Angular velocity of link AO2 or link 2 is given as how much?
1 rad per second.
1 radians per second. Note it down. It is given in the data. Angular velocity of link 2, which is nothing but link AO2, is given as 1 radian per second. So velocity of link AO2 is equal to length of, I'm writing everything in detail for you. So please note down that. Velocity of link AO2 is equal to length of AO2 multiplied by angular velocity of link AO2. Right. सांगा बरं, लेंथ ऑफ AO2 इज इक्वल टू ओरिजिनल डायमेन्शन सांगायचं, स्केल अप केलेलं नको. ओरिजिनल डायमेन्शन सांगायचं ना. किती आहे?
50.8.
50.8. आपण मिलीमीटर मध्येच घेऊया. 50.8 multiplied by angular velocity 1. So it is 50.8 millimeter per second. मीटर पर सेकंड मध्ये आपण कॅल्क्युलेट केलेलं नाहीये, मिलीमीटर मध्ये करतोय. मीटर पर सेकंड मध्ये करायचं असतं तर 50.8 should were required to be calculate were required to be converted to meters. दोन्ही सारखंच. 50.8 millimeter per second. बरोबर? Let us write down here. It is 50.8. Let us change the unit as millimeter per second. आता सांगा मला स्केल फॅक्टर किती घ्यायचा? किती स्केल फॅक्टर घेऊया? 1 सेंटीमीटर इज इक्वल टू, बघा मी स्केल फॅक्टर कसा लिहितोय. 1 सेंटीमीटर इज इक्वल टू 1 मिलीमीटर पर सेकंड घेतला तर 1 सेंटीमीटर इज इक्वल टू 1 मिलीमीटर पर सेकंद इतका घेतला तर 50.8 मिलीमीटर पर सेकंड म्हणजे 50.8 सेंटीमीटर्स येणार. बरोबर ना?
Yes, sir.
बरोबर का?
हो सर.
राईट.
Yes,
सो
sir.
लेट अस टेक दॅट 1 सेंटीमीटर इज इक्वल टू 1 मिलीमीटर पर सेकंड. हे सोपं होऊन जाईल. सो स्केल लेंथ 50.8 आहे म्हणजे 50.8 सेंटीमीटर्स इतकी स्केल लेंथ येणार त्या वेक्टरची. ओके. अँड इन मिलीमीटर्स इट इज 508. आपण मिलीमीटर मध्ये काम करतोय त्यामुळे आपण फायनली काय केलं? वी हॅव डिटरमाइंड फायनली हाऊ मच वेक्टर लेंथ वी हॅव टू टेक इन मिलीमीटर्स, कारण आपण मिलीमीटर मध्ये काम करतोय. बरोबर का? Yes, no?
Yes, sir. Yes, sir.
Yes. So what we did, we calculated velocity of the link in millimeter per second. Then we calculated scale length according to scale factor. आपला scale factor आहे एका सेंटीमीटर साठी 1 मिलीमीटर पर सेकंद. आपले आहेत 50.8 मिलीमीटर पर सेकंद. So we have to take 50.8 सेंटीमीटर्स आपल्या स्केल फॅक्टर नुसार. Now it is 50.8 centimeter. So it is equivalent to 508 millimeters. Next, velocity of link AB is known or not known? Patkan sanga. Known or not known? Velocity of next link AB is known or not known?
Not known.
Known.
Not known.
Velocity of link BC is known or not known?
Not known.
Velocity of BD known or not known?
Not
Not known.
And finally,
known.
velocity
Not
of slider. Velocity of slider known or not known?
not
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 known.
known. Velocity of slider म्हणजे piston. इकडे एका राईट साइडला पिस्टन दिसते बघा तुम्हाला सी. Now let us come to direction. Once again, let me repeat. If we have to draw a vector diagram, we should know magnitude as well as direction. Magnitude is known, rather it is calculated for first link, driving link or crank. For other links it is not known. So let us write it very specifically. Not known at present. At present at least it is not known. Direction of velocity of first link. Direction of velocity of all the links will be known to you. Only thing is, for slider or piston, it is parallel to slider, parallel to path of motion of the slider. And for all other links, it is perpendicular to link length. Please keep this in mind. This is the important point you should note down. I have mentioned it very clearly here. Direction of slider velocity is parallel to path of motion of the slider, and rest of the links except slider have their direction of velocities perpendicular to link lengths. Is it understood? How to finalize
sir.
direction of velocity? Direction of velocity of slider or
Yes,
piston in any mechanism is parallel to path of motion of the slider, and direction of velocity of all other links except slider or except piston is perpendicular to link length. अशा दोनच कॅटेगरी आहेत. Either perpendicular to link length or parallel to path of motion of the slider. When parallel to path of motion of slider, in case it is a slider or piston, there is a slider in this particular mechanism, slider C. In earlier mechanism, there was no slider. Okay, got this point? Yes, no? Write down quickly in the chat box. Please write down in the chat box if you have understood all these points. Everyone, write down yes, no. There are 54 students present, 55 other. Quickly write down yes, no. Please write down quickly. Please do it fast. Please do it fast. Let me know if you have understood whatever we have discussed so far. We have drawn space diagram or configuration diagram. Others, please write down. Please quickly. I should see 54 responses in the chat box.
Sir, hello.
Yes.
I
Manoj.
can't be open chat box, sir.
Okay. See, have you understood? Yes, no?
Yes, sir.
Okay, ठीक है. Others, you can now mute yourself. Mute at your end. Please write down in the chat box that you have understood.
Yes.
The best thing
Yes,
that we are doing is we are directly solving the problem in AutoCAD. So both the things are going simultaneously. Understanding how it is to be done in AutoCAD and understanding how actually velocity diagram is to be drawn. Two things are different. You can draw this velocity diagram manually also. But we have to draw it using AutoCAD. So that is the reason what I'm doing is I'm directly letting you know how to draw velocity diagram using AutoCAD. Others, please do it fast. Please do it fast. I could get 24 responses. Still others. Write down quickly.
Sir, understood, sir.
Understood. Okay, very good. Others, please write down your responses. Those are very important. Your response is very important. It is essential to understand that whatever we are teaching is reaching to your end. Whatever is taught is reaching to your end, to ensure that your response is important in this virtual mode. Now, so let us complete. This is about direction of velocity and magnitude of velocity. Now, since magnitude is not known, so no question of scale. That is also not known. At least at present it is not known. Okay. Right. So this table is ready. Now you can draw velocity diagram. Shall we draw velocity diagram now?
Yes, sir.
Okay.
Yes, sir.
Let us do one thing in between. Let us take your attendance. And then
Sir,
we'll
the
try to
today's
draw.
lecture would be on the recorded in our Moodle, right?
Every lecture will be recorded and it will be uploaded on Moodle.
Thank you, sir.
All the previous recorded lectures are uploaded on Moodle. Every lecture. I don't know how many of you have seen it. Up to yesterday's lecture, every lecture is uploaded on Moodle. But that should be seen. You should go through that lecture. So let us quickly have your attendance. Please quickly respond when allow. 180, 1005. 14. 29. 50. 190. 9001. 9002. 9004.
Present.
9005. पटकन रिस्पॉन्ड करा. 9006. 9008.
Present, sir.
9009. 9008.
Present, sir.
9010. 9011.
Present.
9012.
Present.
9013. 12
Yes,
is
sir.
present or absent.
Present, sir.
13.
Present, sir.
14.
Present, sir.
16.
Present,
17.
sir.
17. 17. 18.
Present, sir.
19.
Present, sir.
20.
Present, sir.
22.
Present, sir.
24.
Present, sir.
25.
Present.
26.
Present, sir.
27. 27.
Present, sir.
28.
Present, sir.
29. 30. 31.
Present, sir.
33.
Present, sir.
34. 35.
Present, sir.
36, 37,
Present, sir.
38, 39, 40,
Present, sir.
43,
Present, sir.
45, 47,
Present, sir. Sir, 45.
47, 48, 51. Okay. Direct second year students, 9001, 9002, 9003,
Sir, present.
4,
Yes, sir.
4 is there,
Yes, sir.
5,
Yes, sir.
6, 7, 8,
Present, sir.
9, 10, 11, 12,
Present, sir.
13, just a minute. Fourteen,
Yes, sir.
15, 16,
Yes, sir.
17,
Present, sir.
18,
Present, sir.
अरे पटकन द्या ना, 19,
Present, sir.
20, 21, 22, 23,
Present, sir.
24,
Present, sir.
25, 26, 27,
Present, sir.
28,
Present, sir.
29,
Present, sir.
30,
Present, sir.
31, 32, 33, 34, 35,
Present, sir.
36,
Present, sir.
37,
Present, sir.
38, 39, 40,
Hello, sir.
hello.
190936 सर प्रेझेंट आहे. नेट स्लो असल्यामुळे आवाज
बरं ठीक आहे, मी नंतर लावतो. 36.
33 प्रेझेंट सर.
नाही, तुम्ही एक काम करा, व्हॉट्सअप वरती तुमच्या दोघांचे नंबर पाठवा.
येस सर.
I will mark your attendance. Okay. So let us move ahead now. What we have to do to draw velocity diagram, I will just give you an idea. What is the first step that we have to follow? What is the first step? consider all fixed points at one location or as common point. Then velocity of the crank O2A. So let us do that. Clockwise direction आहे का अँटी क्लॉकवाईज आहे रे? क्लॉकवाईज आहे. म्हणजे काय करायला पाहिजे आपल्याला? वरती जाईल. So from here ortho off करा. And what is the length? 508 ना? 508 का?
Yes, sir.
508.
Yes, sir.
Right. So 508, but that 508 should be perpendicular to this crank. मग काय करायचं? Go to parametric, perpendicular. या क्रँकला परपेंडिक्युलर, कोणाला परपेंडिक्युलर करायचंय? याला. झालं का? इथं कुठले
Yes,
पॉइंट
sir.
असतील? O1 and O2. याच्यानंतर नेक्स्ट पॉइंट दिस. याच्यानंतर पुढचा पॉइंट कुठला घ्यायला पाहिजे? Right. Next point is this point. If this is A ना, आपण वरती गेलोय, क्लॉकवाईज असल्यामुळे वरती गेलोय, त्यामुळे हा A आहे. So next what we should do, याला परपेंडिक्युलर, परपेंडिक्युलर टू this, perpendicular to this. So let us again draw. याची मॅग्निट्यूड माहिती नाहीये, पण डायरेक्शन तर माहिती आहे. ही लाईन ड्रॉ केली आणि ती याला परपेंडिक्युलर करायची आपल्याला, याला. सो गो टू पॅरामेट्रिक, परपेंडिक्युलर. कोणाला परपेंडिक्युलर? परपेंडिक्युलर टू दिस, आणि याला आपल्याला परपेंडिक्युलर करायचं, पण चुकलं काहीतरी. लाईन ड्रॉ करताना काहीतरी चूक झाली आपली. हां, अशी एक लाईन ड्रॉ करा. एस्केप म्हणा. पॅरामेट्रिक, परपेंडिक्युलर, परपेंडिक्युलर टू दिस, आणि दिस लाईन शुड बी मेड परपेंडिक्युलर. केली. त्याच्यानंतर गो टू दिस. O1 आणि O2 फिक्स पॉइंट आहेत, म्हणजे इथे आहे O2. राईट. परपेंडिक्युलर टू दिस. आपण एक काम करूया, मला वाटते नावं देऊया आपण. नावं दिल्यानंतर आपलं काम सोपं होऊन जाईल. याला नेमिंग करायला लागेल आपल्याला. It is this is O2. This one is A. This is, नावं तरी कंप्लीट करूया आज. रेस्ट ऑफ द पार्ट विल सी इन द नेक्स्ट लेक्चर. O2, then this is O1. नाही, हा C नाही आहे, हा C आहे. This is C. This one is B. This is D. Is it clear now? These are fixed points, O1 and O2. This is A, this is B, this is C, this is D. This one is O1. And then I have started drawing velocity diagram, wherein what I did, I took fixed points at one location and common points. So the common points are, I will write it in small letters, O1, O2. So this is O1, O2, and this one is कुठला पॉइंट आहे रे हा सांगा बरं मला. This is, yes, which is this point? Hello. What should be this point? A. And we will go ahead from this point in the next lecture because it will take time. Let us save this. We will proceed from this point in the next lecture and we'll try to complete velocity diagram. Day after tomorrow, we will complete velocity diagram for this. And if required, we will solve one more problem or we will discuss acceleration diagram. Is that okay?
Yes.
Is that fine?
Yes, sir. Yes, sir.
Okay. So let's stop here. Write your numbers in the on WhatsApp group. Those who are present, those students only should write their numbers, and then I will mark their attendance. There are only 2 to 3 such students.